Good morning, everybody. It's around 11 o'clock, so let's get started. Welcome to the second sector-focused webinar organized by the BioSwitch project this month. Today, we will hear and learn more about bio-based textiles. And before I introduce our speakers, I will remind you on some basic rules. Today's session will be recorded, and we will share the video on social media and on the project's website. We request you to use the chat function when you enter questions. And also, please keep your cameras and microphones switched off unless you are presenting. On the agenda today, we have 3 speakers. Our first speaker is Lien van der Schuren from the Research and Technical Center Centexbel from Belgium. And she will give an introduction on the bio-based textiles sector in Europe. She will be followed by 2 speakers that will inform about relevant research projects. And the first one is Stina Grönqvist from VTT Technical Research Center of Finland, who will inform us on the BBIJU project GRETE. And she will be followed by Mattia Comotto from the company Aquaville, a leading player in the production of nylon 6. And he will inform us on the BBIJU project Effective. Unfortunately, today we do not have a brand owner in our lineup, but for the perspective from brand owners, I'm happy to refer you to the best practice presentation given a year ago by René Bettmann from German outdoor company Vaude. And like all our project outcomes, it is available at the project website. Finally, a few words about the BioSwitch project itself. BioSwitch aims to bring Europe to the forefront of the bio-based economy by encouraging and supporting brand owners from different sectors to switch to bio-based approaches. The project comprises 8 partners from 6 countries, and half of these partners are cluster organizations charged with implementing regional activities. The 2-year project has a budget of about €1 million, and it is scheduled to run until May this year. Details and project results, of course, can be found at our project website, bioswitch.eu. This was my short introduction, and I'm happy now to hand over to our first speaker, Lien van der Schuren.
Thank you, John. I will share my screen first. So good morning, everybody. It's really my pleasure to be able to tell you today a bit more about the bio-based textile industry in Europe. So my name is Lien van der Schuren and I'm working at Centexbel. And first, to understand why we from Centexbel are giving this talk today, I will shortly introduce you what Centexbel is and what we are doing. So as mentioned already by John, we are a collective research and technical center located in Belgium. Historically, our activities have always been on textiles, but due to the correlation between textiles and plastics, we are also now working a lot on plastics. In total, we are with about 180 people at 3 different locations in Belgium. If you look to the activities of Centexbel, you can see that they are divided over 2 main focus points, which is R&D and testing. In order to be able to do these activities, we have some well-equipped testing laboratories to do all kinds of physical, chemical, fire, microbiological testing. You can imagine that we tested lots of face masks in the last 2 years. And in order to do our research activities, we also have some pilot platforms available where we can do the full textile value chain, going from the extrusion of filaments at pilot scale, then also making the textile intermediates like woven fabrics, knitted fabrics, and also the coating and finishing. And this allows us to do all kinds of research on textile and plastics materials. So mentioning then our research strategy, what's important to know is that we are a research center, we are not a university. So we do not conduct fundamental research, and what we do is always in relation to the companies and in relation to what companies are looking for. Also, sustainability is really important to us, which we try to tackle via being efficient with the resources that we have. Also, a lot of focus on recycling and circularity of our materials. And then, of course, the use of biomaterials and biopolymers. And that's why we are giving this talk today. So let's then have a look to what's the textile industry like at this moment. Important to know is that actually the global demand for textiles is expected to double by by 2050. So this means that there will be a high need of materials to be used in the textile industry. At the moment, it's polyester and cotton, which are the most often applied materials in textiles. But these standard materials often have a high environmental impact. And you can see some examples in these graphs here below, where you see the impact of on the water usage of the textile industry. Also, there is a lot of microfiber release coming from textiles. And in general, 10% of the global gas emissions is also coming from the textile industry. So the textile industry is really having a high impact on the environment, and also lots of the materials which are being used, they come from fossil fuels. So we also depend on these and on the price of these fossil fuels, which are increasing. So that's actually why there is a strong demand of the textile sector in general to become more sustainable and to find greener solutions. And of course, we have lots of bio-based materials which are emerging, so we can nicely make the link between these two. So making the link between these two can tell us that actually lots of the bio-based polymers, biosynthetics, which are currently available, they are identical to the fossil fuel counterparts, which makes their usage or their switch to make use of these bio-based alternatives more easy. Also, in general, actually, lots of these biopolymers are processable with the existing equipment. And as I mentioned already, polyester and cotton are the materials which are most often used in the textile industry at the moment. So if you can find an alternative, a more sustainable alternative to these polyester and cotton materials, you really will have a high impact. Also good to know is that the textile industry, or the textile industry in general, is a very varying industry with lots of different applications, which also have all different needs. So this makes that you can have a certain biopolymer and couple this with the application in textiles, which makes the most sense. Also, if we would make use of the bio-based feedstock, which is available in Europe, this would allow us to use a local feedstock. And using this local feedstock, it can also help us to bring part of the production value chain of textiles back to Europe, which will also help to make the textile industry more circular. Of course, there are a lot of opportunities to work with bio-based materials in the textile industry, but we also have still some challenges which we have to tackle. And the first is that, as I mentioned already, there is a lot of bio-based materials commercially available, but they still come often with a higher cost. And some of them are not yet optimized to be used in textile applications. And here in the table below, you see an overview of bio-based polymers, of which Centexbel thinks they are interesting to be used in the textile industry, and what's their price indication and their availability or their possibility to be used for textiles or fibers. So I will not go through this table in detail for all, but important to mention is, for example, PLA, which has a relatively good cost indication, and which also has properties which is in between the properties of fossil-based materials, which are now used in the textile industry. Other interesting materials to mention are, for example, PBS. Disadvantage there is that it's not yet fully bio-based at this moment. And also biopolyamides really are an interesting material, but they still have a quite high cost. Further, what is also seen in general, as I mentioned already, in the textile industry, there is a clear need to go to greener alternatives. This is the case for textiles, but it's actually the case for the whole industry in general. So there is really a high demand for bio-based materials, and at the moment, the demand is higher than the supply. So it can be difficult to acquire the bio-based materials that you need for your application. Also, there can be some confusion between bio-based and biodegradable. It's not that we want to have all textiles being used now to have them biodegradable. This is only of interest for some specific textile applications, like for example, agro-textiles which are being used on the soil and which can then just stay on the soil after their use life. In general, our preferred end-of-life option is to recycle and to reuse our biomaterials. But at the moment, since the limited amounts of bio-based materials which are already on the market, the recycling units are not yet ready to do this. So what can then help to make this bio switch and to boost this? As a first, there are many initiatives which are running on bio-based textiles, many projects, many partners which are working together to get this done. They focus then on improving the bio-based materials and make their properties more suited to use in textiles. Also, what they do is they actually deliver a proof of concept that indeed it's possible to make these sustainable, more green textiles based on bio-based materials. So there's also a lot of circular value chains which are being set up and where we have actually each partner represented and also committed to make the shift. There is also an EU strategy coming up for sustainable textiles, which is expected in the first quarter of 2022, which will also help to further boost the switch. And at Centexbel, we really aim to support this transition by giving trainings to companies, by giving consultancy, and also running lots of research projects on bio-based materials. And to end my talk, I will just give some selected examples of what we are doing at Centexbel on bio-based. In general, we have built up a quite important expertise on using bio-based materials in the textile industry, both for making filaments as also for doing after treatments like coatings. So this means we went through the full processing step, going to the production of mono and multifilaments, of which you can see here some examples. We also are making the textile intermediates, like you see here, the knits or the fabrics. Further, we work on additivation of these bio-based materials to functionalize them, for example, with flame retardant properties, with antimicrobial properties. And then also the coating, finishing, and printing with bio-based materials is being studied. And here you can see an example of a bio-based print on a cotton fabric. And then two projects which we want to highlight. We have many projects at Centexbel working on bio-based materials, but we wanted to show two today. So the first one is on the GRETE project, where we are developing bio-based clothing, which is also circular and local, and looking for alternative feedstocks for the polyester. And you can see an example of a first dress which has been made out of a PLA material. And also the coating and finishing is being worked on. And here, this is an example of a PHA-based coating. Another project which I want to mention is Bio for Self, which is actually a project already ended. And here we developed PLA self-reinforced composites. We did this in cooperation with lots of companies, and in the end, it also led to commercialization by Confill of these PLA reinforced sheets. And we won several awards for this development. And with this, I would like to end my talk. So thanks a lot for your attention, and I will be happy to answer some questions in the Q&A session or via email later. Thank you.
Thank you, Lien. Yeah, indeed. The idea is that questions will be raised through the chat box. It was great to see that there are so many opportunities and already so much interest in bio-based textiles. But also from the table you showed us, it is clear that quite some research is still be needed. Yes. To reduce the price and also to improve the functionalities. And yeah, some of those research projects, they're on board today. And I'd like to hand over now to Stina from VTT, who will tell us more about the GRETE project.
Yes, thank you. Share my screen. It should be visible for you now. So first of all, I would like to thank you for the invitation to come and present our GRETE project in this event. My name is Stina Grönqvist, and I'm the coordinator of the GRETE project. And I come from VTT, Technical Research Center of Finland. And our GRETE project, it is all about overcoming the bottlenecks of the wood to textile value chain. And GRETE stands for Green Chemicals and Technologies for the wood to textile value chain. GRETE is a 4-year project, and we are now coming to the end of the 3rd project year. So we still have 1 year to go. And the funding that we received from BBIJU is about 2.5 million euros. We have 8 partners from 5 countries, shown here on the map. And our partners are bringing together institutions from research, consultancy, and industry, as you can see here on the map. The overall objective of GRETE project is to improve the existing wood to textile value chains by developing real breakthrough technologies that can open up the identified bottlenecks and enable increased production of man-made fibers here in Europe. So what are these limitations or bottlenecks that we aim to tackle? One is the limited raw material base for the production of man-made cellulose fibers. And then the currently used solvent systems, they are far from optimal. Thus, there is a clear need for alternative sustainable solvent systems. And then furthermore, in the current textile production value chains, especially the finishing treatments and dyeing of textiles causes extensive freshwater pollution. So how do we then tackle these challenges? Well, in GRETE, we are developing new and better technologies for wood pulp modifications, for cellulose dissolution, as well as for fiber quality generation, complying with the sustainability requirements and the market needs. Looking at the image here on right that describes the wood to textile value chain. GRETE is looking at the first parts of the value chain, going from wood to fibers. And as said, GRETE will radically improve the wood to textile value chain by developing sustainable technologies for production of really high quality cellulose-based textile fibers. Of course, it's good to note that we are working on a rather low technical readiness level. And in practice, what we do in this project is that we are developing technologies by which paper grade pulps can be used as raw material for these textile fibers. So we are widening the raw material basis for man-made fibers. Then we are also developing novel and safe solvent systems that are based on ionic liquids. We want to have stable, inexpensive, recyclable, non-toxic solvents that can be prepared from industrially relevant starting materials. And then we are also developing modification procedures that enhance the dissolution of our raw material and that also have a positive effect on fiber quality generation. And furthermore, our modifications enable for the further post modifications. So with these actions, we will end up in increased safety, sustainability and feasibility of the man-made cellulose fiber manufacturing. And as said, so our actions will also enable the creation of water scarce end to the textile manufacturing value chain, as fibers with these novel functional properties open up the possibility for targeted and water scarce finishing treatments. Then a few words about our impact. So GRETE really aims to strengthen the European bio-based industry by creating new business opportunities. We will and we are demonstrating new sustainable technologies that enable materials and new products from European biomass. And this again will replace the need for fossil-based inputs. It will also have an influence on the chemical load and the water consumption. And then, of course, when novel high-quality textile fibers are produced in Europe, the rest of the textile value chain will also be strengthened. And that, again, will create impact on even larger scale and will result in increased competitiveness of the European industry. So, as said, the project has now been running for almost 3 years. And I'm very happy to say that we are well on track. And via our web pages, you will find links to thesis work done in our project. And you can, for example, learn more about enzymatic treatments of softwood kraft pulp, both at high and low consistency. Or you can learn about modeling of fiber production and technical analysis of solvent recovery concepts. Or read about spinning of cellulose fibers from ionic liquids. And you can even read about modification of textiles for functional applications. And actually, you will soon also have access to some additional publications via our web pages. So if you want to learn more, please visit our web pages and follow us on social media. And this was my last slide. Thank you.
Thank you, Stina, for this interesting overview of the GRETE project, which focused on a cellulose-based value chain. And I'd like to hand over to Mattia, who will explain a bit more about the effective project, which I understand is focusing on a sugar-based value chain. So, Mattia, the floor is yours.
Good morning, everyone. Of course, as said by the previous colleagues, thank you for the invitation. It's a pleasure to be here today. My presentation will focus, as you said, on project effective and the impact that the project might deliver to the textile sector. Before addressing this topic, allow me to spend a few minutes on the background where Project Effective operates. I guess everyone is aware of the global situation. Sustainability was an added value even before the pandemic, but now is become, let's say, a key requirement for all market sectors. Particularly, the plastic and the textile industry are experiencing a significant pressure towards the development of more sustainable solutions and products. And in this scenario, I think there is no doubt that decoupling processes and material from fossil resources and making them from renewable feedstock is a step forward toward a more sustainable plastic and textile sector. But this is probably not enough. Indeed, should these bio-based products at the end of their useful life find their way to landfill or incineration, I think we can all agree that the benefits of producing them from renewable resources will be somehow limited. So starting from this assumption and considering that the company I work for, which is named Aquafil, has a strong circular economy identity born with the establishment of a unique industrial process that chemically recycled through a depolymerization technology, nylon 6 from a wide range of waste, pre and post-consumer waste. In 2018, we launched Project Effective, that is basically a research and development initiative funded by the bio-based industry joint undertaking that has the ambition of not only demonstrate the production at pre-industrial scale of bio-based polymers, and specifically of bio-based polyamides and bio-based polyesters, but also to validate them in the manufacturing of large consumer products. And most importantly, to validate end-of-life solutions that close the loop in the material cycle. An ambitious project that basically involves the entire supply chain, from feedstock producer to biorefineries and converters up to the final brands. And unlike someone could think, the consortium was not structured from the beginning of the value chain, meaning from feedstock producer, but from the end. Indeed, the first requirement was the availability of end-of-life solution for the targeted bio-based materials, such as chemical recycling, mechanical recycling, or composting. Then we built the consortium backward, working also on a concept that is even more important than the processes that we are developing. And I'm referring to the design. As you certainly know, today most of products, and especially the textile products, are not designed to be reused, repaired, or recycled at the end of their useful life. So we decided to work in cooperation with brands and the other partner of the supply chain on the design phase in order to ensure circular end of life to the targeted products. And this is of extreme importance, regardless whether products are made out of crude oil or out of renewable feedstock. So starting from the end of the value chain, the project is targeting the demonstration, again, at pre-industrial scale, of 3 main bio-based polymers, which find application in the framework of the project into 5 different markets, but that can be potentially applied to a wide range of other industrial and market sectors. For what concerns the textile value chain, the key products is bio-based nylon 6, a polymer that everyone knows, but that is made to a process that you don't know. Indeed, this bio-based polymer will be produced through an innovative technology developed by Genomatica and Aquafil that starts from sustainable sugar, and that will allow to produce bio-based nylon 6 that can be reprocessed into yarns and finally used to manufacture eco-design carpets and garment solutions. Also, as anticipated at the beginning of the presentation, to ensure the circularity, those products will be designed in a way that bio-based nylon 6 could be recovered and chemically regenerated through Aquafil technology of chemical depolymerization. The successful demonstration of such a technology and supply chain, but also the successful demonstration of the overall project concept, if implemented at a commercial scale after the project end, has the potential to generate significant benefits, starting from demonstrating that everyday materials can be produced from alternative resources other than oil, and that they can be used in a more conscious way to manufacture product with the end in mind. This will not only contribute to decarbonize the textile sector, but also to different European policy toward reaching the final goal set in the European Green Deal. Of course, these impacts become significant only when all technologies are upscaled at full industrial scale. For the time being, we are still have some work to do before reaching this phase. Indeed, we have successfully finalized the pilot phase with all processes developed and with the produced biomaterials validated in the manufacturing of products. Now, the project is entering the most interesting and challenging phase with the demonstration of the technologies at pre-industrial scale and the subsequent validation of the so-produced biomaterials into final prototypes of eco-design products. A lot of work was done, and along this long journey, because we started in June 2018, there are many topics that we have learned and that should be always considered in developing new textile solutions. First of all, and probably the most important, is that sustainability drives all development, and specifically the environmental footprint of new solutions. Regardless, materials are made of waste, out of waste or out of biomass, all new solutions need to have a significantly lower footprint compared to benchmark materials that are currently used. Otherwise, the benefits of introducing new products will not be relevant. Secondly, and as important as the first point, is that in the textile sector, the introduction of new and more sustainable solutions will not be enough if we don't work at the same time on the design. A new generation of products designed with the end in mind is required to fully exploit and leverage the circular potential of new and more sustainable solutions. Last but not least, the deployment of more sustainable ingredients should, in my opinion, rely on solid and transparent technologies. The possibility of allocating bio-based and sustainability features to products that are actually made from crude oil and where there is not a single atom of carbon that comes from biomass is definitely not a solution that fosters a more sustainable textile industry, but it is likely a threat to the genuine circular economy and bioeconomy initiatives that were presented today and that are running at the European level. So this is all, and I hope I will have soon some interesting news to be shared with you. Thank you again, and happy to answer any question.
Yeah, thank you, Mattia, for this also very interesting overview. And I agree with the comment made of one of the participants, Dhruv Raghunath, in the chat box, that this textile value chain, where you started at the end of life and then sort of worked backwards, is very interesting and indeed highly relevant one. And the second point that I picked up from your presentation as being key is the circularity. And you even mentioned it might be competitive if we just purely focus on bio-based. So in that sense, it's good to see that BBI has now evolved into circular bio-based Europe. But yeah, there are some questions already. Everybody's invited once more to put questions in either the Q&A or the chat box. And the first question came from Dhruv Raghunath, and it's meant for Lien. And the question is, how would national economies and industries switch from synthetic based textiles to bio-based ones, given that the technology is present, but not the implementation? Lien, can you share your thoughts on that?
Yes. So let's say, in general, we think we should first go to applications where bio or the use of biomaterials also makes sense, and where the higher cost will not be that much of an issue. So we're looking for the right application at this moment for the bio-based materials. And if this can be successful, it can really be like a proof of concept and be a drive to make the switch and to also make the demand higher and thus the costs lower. I would say first look for the right application where it's most fitting, and then this could help to make the switch.
Yeah, so basically, yeah, makes sense. Yeah.
Yeah.
Okay. Yeah, well, on behalf of Ruth, thanks for your answer. Well, we welcome other questions. Again, these can be raised either through the chat, through the Q&A box, or even we can open up the mic for you if you don't feel like typing. There aren't too many people raising questions right now. You may feel a little bit shy, but there's no need for that. After all, we managed to have 64 people on board by now, which is a nice number, I would say. Okay, if there are no questions from the audience, maybe our experts want to add one or two more thoughts to what they already presented. Okay.
What was nice to see is that indeed Mattia also mentioned about the recycling and closing the loop, so that we also really need to do this for bio-based materials. It's not only for needed for standard materials, but also the bio-based ones should be recycled.
Yeah, we did get a question in, which is there a database of bio-based materials available? Well, I happen to know a little bit about this topic myself. I think that sector-wise there are databases. There is no database available, I think, for the whole bioeconomy, simply because yeah, it's very broad. But there are several initiatives to establish databases. I'm not sure about the textile industry, but maybe you know Lien or Stina or Mattia. Then I have a question. How can we make the transition to a bio-based economy quicker? Yeah, I think that's a bit broad to answer. Then a question to Lien. From all the materials you showed, which one do you expect to be market viable in the near future? So say in the next 2-3 years.
Yeah, then I think the most valid material is PLA.
PLA.
Because the cost is okay, it's not too high, and the properties are also in line with what is needed in the textile industry.
Right.
So needs to be, oh, sorry.
No, go ahead.
For sure, PLA also has some shortcomings, so it's really also a matter of improving that and to work on a better stability towards temperature and humidity, because PLA is sensitive to that.
Right. Now, I was just wondering, is there sufficient PLA available on the market? You mentioned that demand is larger than supply.
Yes.
I've heard that
Yes.
mentioning in relation to PLA already several times.
True. Yeah, for sure. It's at the moment it's still an issue, but Total Corbion is really working on also building a European plant, which will become running, I think, in next year or the year after. So this will hopefully help to get the volumes higher. But indeed, at the moment, it is an issue because of the high demand everywhere for bio-based materials.
Yeah.
And then also, I would think the biopolyamides are also really interesting materials because they have really good properties. I would think there the cost is the main issue still, but maybe Mattia can comment on that.
Well, I would say that for at least for bio-based 906, it's a bit early to talk about prices because as reported in the presentation that I've shared, we have just started the demonstration at pre-industrial scale. So we need the data and information from our plants over the next 12 months in order to have let's say a better idea on the economics of the process. But I'm confident that by running the plant for several weeks, 24/7, we will get all the information and detail that are needed to have a more clearer picture on this.
Okay, thanks, Mattia. That sounds very interesting. We'll be curious to learn about the findings that are still upcoming in your project. So as you said, the proof is in the pudding, you could say, and there's still an exciting phase to come in the project. Are there any more questions from the audience? Yeah, is there one more? Yeah, I have here a few more questions indeed. Question from Roy Brooks. How long before bio-based materials move from pre to fully industrial adoption? Yeah, any of the speakers?
Very interesting question. I think there is no just one answer to this question. I think it depends also on the technology that you are developing. If the bio-based polymer that you are developing is a drop-in material or a completely new one. But in any case, a significant investment probably is foreseen for implementing this new technology at full industrial scale. So from the demonstration up to the commercialization, my personal opinion is that between 3 to 5 years are required.
Okay, well, 3 to 5 years is still manageable, I would say, but that's, yeah.
Let's say also with the right economic environment, because perhaps in pandemics, everything is more complicated. Yeah,
I understand that. Yeah, and of course, the you probably will require certain support to make this happen, and everything needs to come together. A further question from Andrew Johnson is, what efforts are being made to standardize bioplastic materials? Or is this left to the market dynamics and brand names? Also, should we limit the number of different bioplastics to help reduce complexity at the sorting stage of recycled materials? So this question is not really too much about textiles, but more general about bioplastics. There are so many different, apparently, shouldn't we limit the number? Well, maybe Lien, you can say something about that.
Yeah, true and not true, I would say. Indeed, there are many bioplastics which are being biopolymers, which are being developed at this moment, but we also have many fossil-based polymers, and it's just a matter of different properties. And for a certain application, you need other properties than for the other application, and you have to find a good fit for the needs, and then the biopolymer which is there. So yes. But anyhow, I do think that history or the future will learn which ones are the most interesting ones, and these will be present in highest amount. There are still so many developments going on. Yeah, it's good that many people are looking for solutions. We will see which one is the most interesting a bit further in future.
Yeah, and also I think if eco-design considerations are kept in mind, then there is no per se a harm in having more different materials.
No, and then of course you can try to, for one material you can try, or for one product you can try to use only one polymer type, for example. That's possible, but it will still be, it can be that for one product it's that biopolymer and for another product it's another, but at least within one product you can aim for using not too many different ones.
Yeah, I understand. Yeah, okay. And then the question from Mehmet is, which standard method will be used to confirm biodegradation? Yeah, I think there are standards already in place, European standards to measure biodegradation. Yeah, I can answer that question after the webinar, look it up for you if that's helpful. I don't think it's really directly related to textiles. Guys, do we have more questions or is this it?
I see from the chat box that there is a question for me.
Ah, okay. Oh yeah, there are a few questions. Oh, the questions are arriving. Okay. Okay, so maybe you go first, Mattia.
Yeah, the question is how much of a burden is the cost of LCA in new technology development? Well, in my opinion, it is fundamental to have an LCA that is validated by the independent third party. So it's not run by only the company that is developing the technology, but is also verified by an independent third party. And this is a fundamental requirement to compare the new solution with the benchmark product. Because in case the environmental footprint of this new solution is worse than the benchmark material, we have an issue. And we definitely need to find solutions that have a lower environmental footprint compared to the current available materials in order to progress toward a more sustainable textile industry, but also in general to a more sustainable economy.
Yeah, so LCA is key to the progress, we can say. Good. Then I have a few more questions in the chat box for the GRETE Project. So for Stina, the first question is regarding GRETE Project, when the textile finishing market could expect bio-derived binders based on lignin?
Well, lignin is not in the focus of GRETE Project, but lignin is, of course, a really interesting raw material. So yes, I expect that lignin-derived binders could be future, but I don't dare to say when based on the project. Yeah.
No, I can imagine if it's not within the scope of the project, then that's a bit beyond. Yeah, okay.
No.
But another question was the GRETE Project is focused on the initial steps, initial stages of the textile value chain. Do you think the technology will be viable in the future for a larger scale?
I have to say that yes, of course we are doing the calculations now in the GRETE Project, but everything is now planned so that it could be viable also in the larger scale. We are looking at pulp modifications that can be upscalable, and we are using like simple chemistry or enzymatic modifications. We are looking at novel solvents, and one of the criteria when selecting and developing these novel solvents is that they could be upscaled to industrial scale use.
Okay.
And all the treatments, yes, so definitely yes.
Okay, well, that's an interesting and good perspective. Talking about perspective, here's the question from Roy Brooks. What outside R&D would accelerate the development of the commercial ecosystem, like legislation, finance, knowledge? In other words, what is key to make the change and to make a faster change from fossil-based to bio-based textiles? Any views on that from anybody? Maybe you, Mattia?
Yes, well, definitely the legislative scenario is a key factor in the, let's say, the final mile towards the full commercialization of bio-based product. But I would say that is not only for bio-based product, it's something that bridge circular economy and bio-based economy. Again, following the concept that I have shared during my presentation, making bio-based product is not enough. And we need to make bio-based product that can be fully recycled at the end of their useful life. Those products will be in any case in competition with the benchmark one that are made out of crude oil and perhaps using linear value chain instead of circular one. So if the legislative scenario helps with the adoption of those circular bio-based models, definitely this last mile toward the full commercialization and adoption will be easier.
Yeah, so for example, if legal requirements are set for circularity, that would be beneficial. Okay, then I have a question from Danielle. Are there standards to grade specifically bioplastics and biotextiles, or are they only compared against existing standards for fossil-based plastics and textiles? I think, Lien, that could be an answer for a question for you.
If with standards, it's the properties of the textile materials are meant, I would think yes. Then it's similar for all textile materials. So there's no difference in between bio-based or fossil-based ones. The only thing which is different are the standards for biodegradability, for example, because that's typical for bio-based materials. But other properties, they are similar.
Yeah. Yeah, that's what I also understood. Okay. Oh, yeah. And another question from Daniel. Are there any particular applications or sectors where it may be preferential for a bioplastic to be biodegradable rather than non-biodegradable?
I would say yes. There are a few. You can think, for example, about in the agriculture, there are often textiles used on the soil to protect the plants or from growing, how to say, protecting the plants, let's say. They use some textiles, and it's difficult to get it off the field after the use life. And then it would be good that after actually the use period, it depends for which type of agro-textile you're using. It can go from 6 months to 3 years, but at least after their use period, they just biodegrade in soil without giving microplastics, without giving any ecotoxicity, of course.
Right. Yeah, you're referring to, for example, agricultural mulch films.
Yes, yes.
But also to geotextiles when you plant trees and you need to give them some protection.
Yes.
And you don't have to spend the effort of removing the protective material afterwards because it will biodegrade. And indeed, you're pointing out no microplastics and no toxicity. Now, that are, of course, essential requirements.
Yes.
Yeah. Okay, that's the last question I see on my screen. No, yeah, that's it. Did I miss anything? No, I think I have them all. If I forgot one, my apologies. Well, thanks everybody for your contributions to this webinar, which I think was highly interesting. In the end, we had about 60 participants, as I said before, which is also a nice number, considering there are so many webinars organized these days. Thanks for all your contributions. Thanks for questions. Next week, there will be another webinar in this series from the BioSwitch project, where the focus will be on bio-based chemicals. And yeah, I think that's the end of this webinar. So thanks and see you back next week, maybe. Goodbye.